Number one, let's condense these two terms into one. Since they're being subtracted, it'll be log that over that, like this. And now that we have one log, we can go from log to exponential form by going this to the power of that equals that. Or of course, we know that that's just 16. And now this looks kind of weird. Now we're trying to solve for x. So it's in the denominator. Maybe what we can do is we can multiply both sides by the denominator. So both sides will multiply by 5x plus 10, 5x plus 10, parentheses there. These are gone. We can distribute the 16, and that'll be 80x plus 160 equals 8. Then why don't we subtract the 160 from the other side? So minus 160 minus 160, that'll be negative 152. Divide by 80. And on a calculator, reduce that fraction, negative 19 over 10. Yeah, you can reduce top and bottom by 8, it seems like, to get this final result for number one. Now for number two, why don't we subtract the 6 from the other side? So that'll be negative 9 times 12 to the 9x minus 2 equals, if you subtract 6 from that, that'll be negative 31. And then we can divide both sides by negative 9. And these are gone. So that'll be 12 to the 9x minus 2 equals, the negatives knock out, it's 31 over 9, like so. And now look, what we have is an exponential form. Maybe we can take this like we did in class and rewrite it to make it look like a logarithmic equation. That would give us log base 12, and then 31 over 9 goes in here. And the exponent is what always goes in the back of the log equation. That's always how this works. And that's good because the exponent now goes, the variable which was in the exponent, now it's sort of in the bottom. And now we can isolate it quickly. So maybe what we can do next is we can add 2 to the other side. And so we have log base 12, 31 over 9 plus 2 equals 9x. And to solve, we can divide by 9. So here's our final answer. There we are. So that takes care of number two. So for number three, looking at the left-hand side, we have logs with the same base. Maybe we can take those two logs and combine them into one. Since they're being added, it'll be log that times that, like this. So here we are. And so we combine the two logs on the left into one. Maybe we can distribute the 8 from within. And now notice that what we have is a log and a log, but they have completely different looking bases. But we know what to do. In that instance, maybe one of these is to become just a number. You can't type that into a calculator because you don't know what x is, but you can totally type that into a device. And if you do that, that actually ends up just being -4, right? So calculator said, boom, boom, that is just -4. And now that's good because what we have can now be written in exponential form where we go this to the power of that equals that. And now, so we have 3 to the power of -4 equals this. 3 to the power of -4 is 1 over 81. And then to solve for x, maybe we can add 16 to the other side. So it'll be the fraction plus 16 equals 8x. And to finish, you can divide both sides by 8. These are gone. And honestly, just type all that crazy looking stuff into a device and it'll say whatever the answer key says. So x equals 1297 over 648.